Hello, we are MATLOK Innovation. Thank you for taking the time to learn about our concept capability. SEAFRONT. Our company has a vision to solve imminent long-range flight test challenges using state-of-the-art methods. Our concept solution, SEAFRONT, uses emerging technologies like NVIDIA's Omniverse to model and simulate complex flight tests, enabling fast turnaround planning using fewer subject matter experts. In addition to planning test execution, we will use AI to perform optimization of multiple flight tests, maximizing the efficient use of high-cost, low-availability instrumentation capabilities.
I want to quickly give the context of our use case, perspective, and vision. Intercontinental missile tests, generally conducted over the ocean, currently take 6 to 18 months of planning. It takes dozens of SMEs working together to project missile flight paths, simulate and model safety fans, and overlay them with instrumentation asset coverage fans of telemetry and flight safety systems on land and deployed across the ocean. Currently, SME-level knowledge is required about each instrumentation capability because they are generally one-off and unique, like the one shown here. Putting urgency to this problem is the Golden Dome and hypersonic weapons efforts, which will increase the number of flight tests by over 10-fold what we execute today.
The DoW must find a way to optimize complex flight tests in multiple domains to include logistics, safety and risk, RF systems and spectrum management, and others. And we must find a way to perform that optimization planning using fewer people in less time. The DoW's first step is well underway. The Test Resource Management Center is addressing the gap in instrumentation asset availability. They are mobilizing and scaling telemetry and range capabilities to meet future demand and need for flexibility. The most well-known investments in this category are SkyRange and Mosaic, the modular open systems architecture instrumentation container. DoW's next step must be optimizing the use of these assets. Emerging technology like NVIDIA's Omniverse and OpenUSD formats provide the means to do this. Using Omniverse and one-day DARPAverse, we can develop test plans in 3D space much more effectively and efficiently than in the past. We can use existing SysML, CAD, and 6DoF simulations to build universal descriptor-compliant models of missiles and flight test support assets. We'll integrate those models into NVIDIA's Omniverse. That, among other things, will compose those systems into codependent platforms and platforms that interact. With models of everything involved with a missile flight test, integrated into a global-scale simulation, allows us to plan out flight tests, visualize and analyze instrumentation locations, and assess logistics such as transportation times and costs of fuel, vessel leases, and operator costs. And this tool will be extensible and scalable in many ways. First, we'll have the ability to plan entire test campaigns where multiple flight tests are coordinated to share test support assets. And by enabling capabilities already inherent to Omniverse, we'll soon be able to use AI to plan test campaigns that are optimized in multiple domains, minimizing risk, providing cost efficiencies, and making testing more effective with a right-sized inventory of test support assets and operator workforce. We'll even be able to perform trade studies that inform investments in instrumentation, ensuring we have the right quantities, types, and technologies.
In conclusion, the DoW needs to invest in test planning to meet the imminent instrumentation asset gap that will be caused by an order of magnitude increase in flight tests in 5 years. Even with new instrumentation assets such as SkyRange and Mosaic developed and scaled, there are remaining gaps that must be filled to effectively support programs like Golden Dome and the hypersonic missile arms race. The DoW must replace the status quo of test planning because how we do it now cannot be scaled to meet future demands. What is required is a new ability to plan much more complex tests without sacrificing safety, and it must conduct planning faster and with fewer resources. And planning needs to include optimizing the usage and logistics associated with the assets that are available. The good news is state-of-the-art technologies make all of this well within the realm of the possible. By generating new and converting legacy models into reduced-order OpenUSD format models and importing those models into world simulations like NVIDIA's Omniverse, we can increase the speed of modeling and simulation, test planning, and optimization analysis dramatically. With the addition of a user interface and code designed to support our specific use case, our solution, SEAFRONT, will enable users to efficiently plan tests with consideration across multiple domains. Tests can be more complex, and orchestrating test support assets along a continuity of operations mentality will increase users' knowledge and soon provide near-automated logistics planning. The DoW's long-range weapon test readiness will be greatly increased, while small numbers of users will be able to do in days what currently takes man-years of effort.
The next step is to implement natural language orchestration and allow AI to optimize test plans. We display a simple example in this demonstration, where one complex flight test could be optimized based on knowledge of a precursor test. But the greater potential value arrives when AI can be provided all the information on what flight tests are needed, and it orchestrates entire test campaigns, optimizing instrumentation assets, people, and costs while reducing various risks.
Lastly, consider SEAFRONT as a pathfinder for the future management of the DoW's test enterprise. Expanding the scope to include all major test support platforms, data collectors, sensors, and operators, including land, ocean, and space ranges, and combining a unified approach to managing flight test needs. Our proposed solution, scaled and expanded, can realize a new future of testing at speed and testing at scale efficiently across all domains of interest.